What's good? We're just going to jump straight into it. Very interesting chapter. I know we didn't use a lot of numbers. We had a lot of different logic problems, a lot of reasoning and critical thinking. And I don't know, I'm going to miss this chapter, except maybe not the proofs. Just jumping straight into it. Which of the following is a counterexample for this conditional statement? If a number is positive, then it is spelled without the letter E. Okay, well, let's think about it this way. We want a counterexample, something that proves this false. If a number is positive, then it is spelled without the letter E. Well, that's not necessarily true. Just because a number is positive doesn't mean that it's spelled without a letter E. We can think of plenty of numbers that are positive but have the letter E in it. So if you want, maybe just write down 1, this is 2, you spell this as 6, and then 4 this way. Now, here's the thing. We don't want to pick the ones without the letter E. In fact, we want to pick the opposite. We want to pick, for example, this one. We don't want to pick these, okay, because those are actually not counterexamples. We want to find a number that's positive, but is still spelled with the letter E. And it turns out this bad boy right here, this has the letter E, right? So obviously, this conjecture is false. Okay, we just proved that. Okay, that's the counterexample. Okay, let's look at this next one. If a boy is tall, then he is good at basketball. If a boy is tall, then he is good at basketball. Okay, well, that's not necessarily true. You could be tall, but still not be good at basketball. So that automatically eliminates some of the answers that we have here. For example, this one says short, and this one is short. We don't really care about the short boys. Sorry. I'm saying that as a short boy myself. You know, oh well, short kings don't really matter here. So goodbye. How do I? There you go. Okay, I'm just going to pretend those are X'd out. But we do want to have an answer where the boy is tall, but is not necessarily good at basketball. Well, this one is tall and good. Unfortunately, that's not what we want. We want someone that's tall, but is still bad at basketball. So the only answer is going to be Franco, okay? This is the counterexample. Because think about it. We want to prove this false, right? We want to prove this false. Well, if a boy is tall, then he is good at basketball. Well, no. Franco is tall, but terrible at basketball, unfortunately. Okay. Okay. Let P be you are a high school student, and let Q be you are human. Okay. This one is kind of interesting. Remember, these are conditional statements. I will refer you back to this table right here from 2.1. Make sure to refer to your notes. And this tells us that a conditional statement is if P, then Q. Okay, so we're going to deal with that first. So make sure you know exactly what a conditional statement is. A conditional statement that I'm highlighting right here is going to be in the form if P, then Q. And remember, this is P, this is Q. So if we want to write if P, then Q, well, I'm going to just draw a dividing line here. If P, then Q is going to be if, then, and it's going to be if you are a high school student, then you are human. Okay? Now, is this necessarily true? Let's think about it. If you are a high school student, then you are human. Well, the last time I checked, if you're a student, I mean, unless we're enrolling Martians or aliens on this life, I don't know. I don't think I've heard of that. I think all students are indeed human, and so this is going to be your answer. Okay, true. Okay. You don't really need to write an explanation on the test. It's going to be multiple choice. So obviously, just remember why it's true. You don't have to actually explain in this case, but you should know why. Next one. If you are a high school student, oh, sorry, I'm reading it wrong. Let P be you are a high school student and let Q be you are human. If you notice, these haven't really changed. These are not going to change in the next couple examples. This time we want to write the converse, okay? Converse. So I'm going to write the little dividing line. What is the converse? Okay, I'm going to pre-highlight this. Let's go back to our handy dandy reference table. Boom. Converse is if Q, then P. Okay, so if Q, then P. So this comes first, okay, and then this comes after. So let's write that down. If, then. If you are human, then you are a high school student. Okay, now let's think through this one. We want to find out, is it true or is it false? Well, just because you're human doesn't mean necessarily that you're a high school student. I mean, you could have been in high school 10 years ago. Cough, cough. Anyways, yeah, you don't necessarily have to be a high school student. That's my point. So this is false. Okay. Consistency of color. There you go. All right, so moving on, we have two more. And again, the problems, the P and the Q are not really going to change, okay? It's just a matter of the order. So this one is telling us, again, same thing, P, then Q. That hasn't changed. But then what has changed is this time they're asking for the inverse. Yay. Okay, what's our inverse? Well, you should have this down. Inverse is, remember, the negation sign looks like this little squiggly. If not P, then not Q. Okay. So let's write that down. Not P, then not Q. So this time, it's going to look a little bit different. So, why am I highlighting it? Sorry. If you are not a high school student, okay, keyword not in this case, then you are, and again, we need the negation just because this is not Q, then you are not a human. Okay. Okay, well, is this a true statement? If you are not a high school student, then you are not a human? No, this is false, right? People that are not students can actually be human, okay? Like last I checked, again, I'm not even gonna make a dumb joke here. Yeah, if you're not a high school student, then you are not a human. That's clearly false. And I don't know why I wrote A. Sorry, goodbye, woo. Yeah, I mean the actual thing says you are human. It doesn't really matter, okay? Ignore me. It's late into the night. Okay. So you are a high school student. You are human. Nothing's changed. This time it's the final boss. This is the contrapositive. Okay. Now again, contrapositive. I don't know why it's one of my favorites. Just so I don't know, such a cool name. And this one says, if not Q, then not P. As you can see, this is this little squiggly, squiggly. So two things are going on here. You want to flip the variables, and then you want to negate them. So not Q, then not P. Okay. Now, for those of you, sorry, there I go again. For those of you that might have noticed a pattern, well, let's write this first. If you are not a human, and again, remember, we're doing Q this time, not Q. If you're not a human, okay, this guy negated, then you are not a high school student. And bam, there you go. Again, this is not Q, this is not P. Now, those of you that might have noticed while you're doing the homework or throughout this chapter is that you always get the same truth value as the original conditional statement, okay? And again, if you're not sure what I mean, what I'm trying to say is that the conditional statement and the contrapositive, if you get a true for this, turns out you get a true for the contrapositive, okay? If you get a false for this, turns out you get a false for this. It's magic, trust me. What I'm saying is these two are actually logically equivalent. And I'm not going to get into it right here, but it is a pretty cool fact. They actually mean the same exact thing. Okay, so let's just jump back to this problem. We already know from what we just went over that this really should be true, just like our original conditional statement was. But let's try to think about this logically. Let's read it back. If you are not a human, then you are not a high school student. Okay. I don't know a single school on Earth that takes in a Martian or an alien or any type of other intergalactic species out there. Certainly, this has to be true. If you're not a human, then you are not a high school student. So, again, I'm just going to write in the answer. I'm just going to move on. If you have further questions, the document that I imagine future Mr. Chung has uploaded to Google Classroom should be pretty handy. It has all the written explanations that if mine doesn't make sense while you're listening to it verbally, you should be able to look at it and hopefully understand it a little better. Okay, this one is called the negation. Negation, remember, negations are just, think of the opposite, but not in the way that you want exactly the opposite. And I sound confusing, so I'm just going to write the answer here. If the statement is, the rain is falling today, well, the negation of that statement is, the rain is not falling today. Okay. And again, you're not looking for anything like, I don't know, the sun is shining today. Like, you're not looking for that. It's simply the opposite in this case, that the rain is not falling today. Well, next question, I am not very handsome. This one already has a negation. So turns out I am very handsome is going to be your negation. I don't even know if that makes sense. But again, we got rid of this guy, because if it's already negated, then the opposite of it would be to make it positive. So I am very handsome, and yes, I am saying that as a statement of fact. My mom told me so, and so I believe it, and you should too. All right. Anyways, awkward. If a student is a human, then they breathe air. If that person breathes air, then they exhale carbon dioxide. In conclusion, if a student is a human, then they exhale carbon dioxide. Okay, a lot of sentences here. Well, this really is a deductive reasoning problem in disguise. And how do I know? Well, recall, if you remember, this right here is the law of syllogism. Okay, this is the notes that we filled out for 2.2. The law of syllogism basically is a facts-based form of reasoning where if the hypothesis is true, then the conclusion is also true. Okay, and this type of reasoning is what you call deductive reasoning. Okay, usually that's 3 sentences. So, for example, remember, here are 3 statements. If a student is human, then they exhale carbon dioxide. Okay. Well, this is in the form if P, then Q. If Q, then R. Well, then P implies R because we can kind of cut out that middleman. Okay. It just goes straight from P to R. Okay. That's all we get. And so this is a type of deductive reasoning because we're using facts. And usually they're in a 3-sentence format. And so we can eliminate the ones that say inductive reasoning. Those are going to be based off patterns, as you're going to see on the next slide or next problem. And again, inductive reasoning is using patterns. This one says pattern. That's the wrong pair. So really, anytime you see this type of sentence structure, let's say there's 3 sentences and it follows this format right here, that's a deductive reasoning problem. Okay, it's using facts. Okay, let's read the next one. And I'm going to already kind of clue you in. Every time I participate in class, my teacher compliments me. So when I participate today, my teacher will compliment me. Okay. Is this in the sentence structure of the previous problem? P then Q, Q then R, then P then R? No, it's actually not. Okay. There's actually only 2 sentences here, so you can kind of clearly see there's not even enough sentences to form that 3-sentence structure. Okay. Instead, you should focus in on this, and I know I'm over-explaining here, but I really want you to understand this. Every time I participate in class, my teacher compliments me. This indicates a pattern of behavior. And so remember, patterns indicate inductive reasoning, okay? And so the previous problem didn't really have any patterns. It just had facts. If P, then Q. If Q, then R. Then P, then R. I should be a rapper. Well, in any case, this problem uses a pattern. Every time you participate, your teacher compliments you. So obviously when you participate today, your teacher will compliment you. That's the pattern you notice. So we're going to eliminate the answers that are not pattern-based. That's not deductive. Remember, deductive is P then Q, that thing. Now, which one of these is the correct answer? Is it going to be A or D? Well, notice inductive reasoning is incorrectly paired with facts, but that's deductive reasoning, right? So that's not right either. We're going to circle the correct answer, D. Kind of messy. Sorry. Inductive reasoning pattern is used. Okay, so let's take a look here. Remember, proofs are always going to give you a true fact, okay? Given ABC is a right angle. So that's already given. We know that ABC is a right angle. Now, the question is, what goes in these blanks right here, okay? What goes in these blanks? We don't quite know just yet, but we're about to, okay? Well, remember, one thing that we can clue you in is the thing that we want to prove. Remember, the given is always going to be here, right? But the thing that we want to prove is always going to be the last one, okay? We want to end up at x equals 8. So we already know what 7 should be, okay? We'll come back to that in just a second. I'm going to zoom out. So number 11 tells us what is reason number 2. What is reason number 2? This guy right here. Okay, well, number 2 relies on measure of angle ABC is equal to 90 degrees. Well, when an angle is 90 degrees, remember, that's just a definition of what? That's right. Definition of a right angle. Okay. And yeah, 90 degrees, that just means right angle. That's all it's saying. So that's basically going to be the reason that follows, that corresponds with this statement on the left. Okay. So I'm going to write that as, you can write definition of a right angle. I'm just going to write definition of right angle. Doesn't really matter. Okay, that's your answer. Now, what is statement 3? Moving on. Statement 3 is the question that number 12 is asking, this guy right here. Well, let's look at the statement across from it, angle addition postulate. Okay. Well, recall from 2.5, we reviewed this concept of if you have two angles that are adding, this guy and this guy, well, then you get just the total angle from here to here, okay? That's just a fancy way to say you're adding two angles. Angle addition postulate, this just means rule, right? So jumping back, what is statement 3? Well, let's take a look. Remember, we're just going to call this angle, let's just call this angle ABD. And if you're wondering why, remember it goes from A to B to D. So that's why we're calling that angle ABD. And then let's call this one angle, we're going to go from the opposite direction. Boom. Let's call this C, B, and then D. Okay. Now that we have those two angles, remember, when you add this angle with this angle, they both need to add up to equal 90 because we know that that's the measure of a right angle. Okay. So that's literally going to be our angle addition postulate. We're going to write measure of angle ABD plus measure of angle CBD is just going to be equal to 90 degrees. And there you go. That's the angle addition postulate. Let's keep going on. Number 4 is already filled out for us, substitution property of equality. We can see that this is a substitution property because this one and this one got substituted in, right? Like this and this are the same. Number 5, though, says to simplify. This is the home stretch. It's pretty easy, hopefully. You know that you can combine like terms here, right? These two should just become 8x. And then you could just combine 14 and 12, and that should give you 26, I believe. Okay, so that's literally all we're going to do right now. Just combine like terms. And once you do that, then you've listened to the reason on the number 5, which says simplify. Okay. Oops, forgot to fill these in. According to what we just filled in, measure of angle ABD plus measure of angle CBD is equal to 90. And no, I did not just say skibbity, I said CBD. What is statement number 5? We already filled that out. 8x plus 2x equals 90. Okay. And finally, what is reason 6? I mean, not finally, we have one more, but we already filled that one in. Number 6 says 8x plus 26 equals 90. Well, how do we get from step 5 to step 6? How do we get there? Well, if you notice, technically, your next step would be to subtract 26 on both sides. And as the laws of algebra would tell you, this would just cancel, right? I mean, what operation do we just do? You guessed it, subtraction. And remember, we got to write that whole guy out. Substitution, property of equality. Oh, sorry. Subtraction. What are you doing? Subtraction. Why didn't anyone tell me? I'm losing it. There you go. That's the proper spelling. Okay, because we subtracted on both sides of the equation, right? The equal sign, we're going to call it the subtraction property of equality, which is the number 14 solution. Of equality. Okay, I know it's a little tedious. I assume you guys are just jumping around listening to the timestamps. Number 7, finally, how do we get from step 6 to 7? How do we get there? Well, all we did was division property according to the right side. So that is exactly what we did. Divide by 8, divide by 8. And again, let's assume this wasn't here, right? I mean, we should know that, 64 divided by 8 is just x equals 8. Boom, there's our solution. But if we didn't know that, again, we just look at the proof right here. This should have been your last blank anyways, okay? If it wasn't, then you probably missed a step somewhere. So that's your answer. Now, if this wasn't clear, again, proofs are just a little bit tedious, so I went a little fast. Please reach out to me in class to get some clarification. Let's move on to the final 6 review problems from the previous chapter, because this is going to keep coming up over and over again in geometry. Okay. So find the measure of angle B. So I'm going to highlight this angle. What kind of angle is this? Well, this is a 180 degree angle, right? It's a straight angle, otherwise known as this is a pair of supplementary angles. So we know that this is going to add up to 180 somehow. So let's see how to get to 180. Well, just add up the two angles, right? You know that these two should add up to 180, right? So 134 plus b is equal to 180. Let's subtract 134 from both sides. And yes, if you could do this in your head, then you can totally do that, but I'm showing the algebraic way. This should give you 46 degrees. And how do you check this answer? Well, plug it back in, okay? Plug it back in, Sherlock. This is 46. If you add those two together, in fact, you should get 180. You have my word, okay? Find a measure of angle B. This is the next problem. Well, angle B in this case is a 90 degree, right? You could tell by this little square symbol. So 47 plus B, or B plus 47, doesn't really matter, should add up to 90. Well, try to get B by itself. I mean, pretty smooth sailing from here, I think. B is equal to just 43 degrees, and there you go, okay? Plug it back in to check the answer. I'll do it one last time. If you make this 43, do they add up to 90? Yes, it does. Okay, 2x and x. Well, how do you find the value of x? This is a 90 degree, clearly, so you just need to add these up. Add these guys up. You get 2x plus x. We know that those two need to add up to 90 degrees. These are just like terms, right? This is technically 1x, invisible 1. So that's just 3x equals 90. Divide by 3, divide by 3. You should end up with x equals 30 degrees as your answer. Again, substitute it back in, check your answer. Find the value of x. Again, what kind of angle is this? You may not actually realize this, but if this angle is 90, well then so is this guy. Think about it. That's 90 and 90. They need to add up to 180, right? So this is also a right angle. Meaning this and this need to add up to equal 90. So 2x plus, 23, I'm going crazy, plus 2x plus 1 equals 90. Okay, well, just combine like terms. You can see that these two are like terms, right? These two should give you 24. So let's do that. 24 plus 2x equals 90. And then from here, to get x by itself, just subtract 24, 24. These cancel. 2x equals 90 minus 24. Use a calculator. That's 66. Divided by 2, divided by 2. These cancel. You're going to get x equals 33. Okay. And, you know, oh no, wrong color. Technically, we're solving for x here. I don't know if I need the degree sign. I'll just put it just to be consistent. But actually, I think it's actually more accurate with that. Just ignore me. I'm going crazy. I'm just going to leave it with that. In the previous example, you put the degree symbol because it was just simple. But these are actual expressions. Anyways, doesn't matter for your test. It'll be multiple choice. This one is going to be a 180-degree angle, otherwise known as a pair of supplementary angles. And so they need to add up to that. 1 plus 2x plus 47 equals 180. Again, look at these two. These two are like terms, right? That becomes 48. So 48 plus 2x equals 180. Doesn't matter where that 48 sits, but subtract 48, subtract 48. This is going to cancel. 2x equals 132. Divide that by 2. And then finally, your answer will be x equals 66. No biggie. Last one. Let's say this is 180, right? Because you can see it's a straight angle. It's a pair of supplementary angles. Well, 1 plus 2x plus 33 is equal to 180. Again, these two are like terms. Those are going to combine to 34. I'll put it on the, I'll be consistent. 34 plus 2x. It doesn't matter, but that's the order. 34, 34 subtract. Why do we do that? These want to cancel. That's why. And that's going to give us 146 to my calculations. Lastly, you want to divide by 2. That should give you 73. And that's it. Sorry, I mean, I was a little bit unhinged. I just wanted to get this over with, but I still want this to be helpful. If you didn't understand this, again, you can ask me you can ask questions to me in person, and obviously you can email me or send me a fax or send a pigeon. I don't really care. Okay, as long as you communicate with me, that's what's important. All right, peace.